Hello everyone. Today we are going to show you how to sketch graphs using the sketch means we roughly draw the graph using the conditions given. So we've got two questions. The first question, we are given fx, graph of fx is this. We need to sketch the regional function. So f dash x is this, but what is the regional function should be? So let's have a look in order to do that, let's do some key points. So we have this point, and those 3 points are the key points. So in this point, we know so this point is, so those two points, we know the y dash equal to 0. So therefore, the graph will be either, so be stationary, turning point. So therefore the graph will be stationary point. Could be maximum, could be minimum, or could be point of inflection. So we don't know. So let's see what happened. Second thing is, we know from this section here. So this graph is this point is not only, so this is a point is y equal to dash equal to 0, as well as y second derivative also equal to 0. Why? Because that's the maximum turning point for second derivative or first derivative. So therefore, this is a second derivative must be also equal to 0. So remember, we have two tables. Let's summarize the table we did in last lesson. So we know, so y dash less 0 equal to 0 or positive. Negative, when graph is negative, derivative negative, graph go down. Derivative equal to 0, graph either stationary, maximum or minimum. If it's derivative positive, graph go up. So, but this one, this point is play two roles. One is for the y dash equal to 0, but at this point is also second derivative equal to 0. So second derivative is 0, so must be, we discuss the three options: second derivative negative, second derivative positive. Second derivative negative, we know graph is concave down. And equal to 0 could be point of inflection, stationary. So, or something like that. And the other one is positive, second derivative positive, so concave up. So let's have a look at this. The second derivative is equal to 0. So that means this point must be point of inflection. So this point for the regional function should be point of inflection. But if you put it as, so join together, equal to derivative 1 equal to 0, second derivative also equal to 0. So this must be a point of inflection, which is stationary point of inflection. So we call horizontal point of inflection. Now, have a look at this graph here. You can see this section here is a negative. So if you look at my mouth here, so therefore this graph is go down, regional graph go down. And this is also negative. So therefore graph continue to go down until reach to here. This point is y dash equal to 0 and y double dash also equal to 0. So this one should be another point of inflection. So this is another inflection point. Then third one, so this is a y dash first derivative equal to 0. So this one must be either concave down or concave up. So even maximum. Now, what to do, whether it's concave up or concave down. So if you look at this graph is go up, so that means in this section here, so the second derivative must be, if it's go up, must be positive. So second derivative positive, so it means graph must be concave up. So therefore from here, so this the from here the turning pointers go up. So that's, so this will be the original y equal to fx. So we solved that. So let's move on to question number 2. Now question number 2, we have equation. So we need to sketch the graph for fx. So let's do that. So I'm going to use, this time is a blue, green pen. So we first, if we want to sketch graph, we need some key points. So that means we need stationary points. When you do stationary points, we now need to differentiate. So the first derivative, so it'll be 3x squared plus 12x plus 9. So let's factorize that. So factorize into 2 brackets. So we got, so we say we let f dash x equal to 0. So we will get x1 equal to -1 or x2 equal to -3. So these the 2 key points. So 2 x's. So -1's here and -3 is here. All right, now let's test which one is, so this is the, so therefore we will have in these 2 points, the graph could be station. So fx station point at x equal to -1 or x equal to -3. So, but a station could be maximum station or minimum, we don't know. So we need a second derivative. So let's do the second differentiation. So differentiate to 6x plus 12. So that means it'll be 6x plus 6, sorry, plus 2. So let's substitute either of those, see which, so let's test the first one. So we say substitute x equal to -1 into f dash x. So it'll be 6 minus 1 plus 2. So it will be 6. So it will be positive. So if that's the positive, x equal to -1 is positive. So that means the graph has to be concave up. All right, so the graph will concave up. So then we try next one, -3. -3 plus 2. So the answer will be -6. So we negative, so concave down. So therefore here, all right, so this is the concave up. Now, but we need to find out what is the stationary point is exactly is. So let's substitute. So therefore, we need to find out what is f -1 first. Substitute into equation. So f -1. So we know we substitute the original equation, which is x -1 to the power 3 times by -1 squared times by -1. So the answer will be -1 plus 6 minus 9. So the answer will be -4. So therefore, the first stationary point is at -1 and -4. So this is the stationary point. And this one is concave up. So it means go up. Second one is y equal to YF -3, we substitute -3 to the equation. So the answer will be -27 plus so +54 minus 27. So that means this is equal to 0, isn't it? So therefore, the second point is at -3 and 0, so which is here, but it has to be concave down. Now, then we need to find another point is called have second derivative equal to 0, so that we can decide where's the point of inflection. So second derivative equal to 0, so that means 6x plus 2 equal to 0. So therefore x equal to -2. So therefore here -2, so this is a -2. And this is the point of inflection. So we go down here. So the graph will be, so we join them together. So go up, concave at this point, then concave up. So the total graph will be sketched roughly like this. So this is a concave, this is a stage, this is a point of inflection, and this is the concave maximum turning point, minimum turning point. All right, thank you for watching, and keep practicing, do some homework. Thank you. Bye-bye.